In this video, we're going to use logical constraints with a mixture of matrix inequalities. And specifically, what we're going to do is we're going to sort of work on that last problem where we said we have three binary variables, b1, b2, b3. If b1 is equal to 1, then this is going to imply some a1x less than or equal to b1. If b2 is equal to 1, this is going to imply a2x is less than or equal to b2. And finally, we'll say if b3 is equal to 1, this is going to imply that a3x is less than or equal to b3. And in fact, what we're going to do is we're going to require that b3 can only be 1, sort of if in both directions, b1 plus b2 is equal to 0. So in fact, we can just replace this with a single logical constraint. So we can actually delete all this stuff and just use a logical constraint to indicate what we'd like. All right, so I'm going to go ahead and delete that. And we're just going to make the logical constraint b1 plus b2 is equal to 0. All right. So with that in mind, we'll also, let me move this down. We'll also have, let's say, some maximize C transpose X, and we'll require that all our X values are greater than or equal to 0. So we'll have a non-negativity constraint. Okay, so. All right. So I'm just going to make up random values for C, A1, A2, A3, B1, B2, and B3. And so what I did is I went ahead and just made random matrices, and hopefully this will work out and actually be feasible. But what you can see is I've already gone ahead and labeled them as CMAT. Right, here goes AMAT1, so there's just A1. And then on the right-hand side, you see these are the corresponding B's. And again, they've already been labeled so that they just have to be read in. Okay, so I'll go ahead and save that guy. In Cplex, I've already made the data file to load each one of these. So it's going to load AMAT1, MAT2, AMAT3, BMAT1, BMAT2, BMAT3, and so forth. All right, and we have our CMAT. Okay, so at this stage, both of the map file and I have a blank mod file in here. So at this point, I can start loading in the data. So the first data, again, would be a float, and it would be AMAT1. And again, we're loading this in from the data file. So we can go ahead and just load in all of these guys. AMAT1, 2, and 3. I'll do the same thing with the B's. We'll get them all ready. And lastly, we need to load in our CMAT. Oops. Next, just to make life a little bit easier, because we're working with everything in matrix form, I'm going to go back to one of the programs that I'd written before, where I sort of set up the whole problem to work in matrix form. So this was done in a prior video. So I'll go ahead and copy and paste that in. But I'm going to have to change some of my variables. So again, instead of C here, I have CMAT. X still works. And I need to introduce my decision variable. So we haven't done that yet. So I'll go ahead and create those guys. So there's actually two things we need to do. We also need to define the range in addition to defining the decision variables. And so here we end up, if we go back here, we see that the dimensions of C has 7 elements in it, so we're going to have a range from 1 to 7. Okay, so we're still getting a few errors, not an array type. So we'll figure that out in a second. The next thing that we can do is we can sort of just plug in a mat1 just for fun, and b mat1. Okay, so this is even without doing too much work. Okay. So the one of the challenges here is that we have to know the dimensions of each of the A's. Okay, so we could certainly actually put this in here. So why don't we? So I'll just call it M1. We'll do M2 and M3, and this is going to correspond to how many constraints we have. So in this first one we have 5 constraints, and the next we have 3, and then finally we have 4. So I'll call this num cnst constraint. Oh, it's kind of, yeah. So num constraint 1. This will be num constraint 2. And then finally num constraint 3. Okay, so let's go ahead and save this. Going back to the data file, we now need to bring in load how many constraints we have for each one. So I'll go ahead and open up our dat file. And just to make life easier, I'm going to call this M1, M2, and M3. The reason why I didn't call it M1, M2, M3 in the Excel spreadsheet is sometimes that when you name cells, letter, number, it confuses it with the actual column and row numbers and letters. So usually it's not a very good idea to do it, but we can sort of put it back M1, M2, M3 in Cplex. So again, oops, it did not get the first one, but we'll. Okay, there we go. All right, so each one of these guys are named. Okay, so now we can do the different ranges that we need. So int, so we got to load in M1, M2, and M3. Okay, so we've loaded in not only the A and B matrices and C, and I'll actually put this in a slightly different order just to make it a little bit clearer. We also know how many constraints we have for A1, A2, and A3. That's just given by M1, M2, and M3. So along that sort of thought process, we need to define ranges because we're going to have for loops that go through each one of these, or sums, I guess, and for loops. So, okay, almost done. Alrighty. So if we want to talk about the first constraint, again, if we're doing it in matrix form, it should look something like this. All right. So I'm getting a little bit of an error, so we got to figure out what exactly is going on. So it's saying something is not an array type. All right. So I'm going to pause really quickly to figure out what is going on, or we can maybe just try running it and seeing what happens. Let's see. Because these could be vestigials left over. Sometimes it doesn't clear the errors. Nope, but it certainly does. Impossible to load model. So it's complaining about a few things. Not an array type. So it's probably the range here. And CMAT, it's complaining about an X. All right, so I'm going to try to remember what I did wrong and hopefully fix that. I feel very silly. We actually need to define the size of each of these vectors, the C mat, A mats, and B mats. So we'll go ahead and do that. So we kind of actually have to put the n up here first. Okay, so the dimensions of C mat and all these guys need to be defined after the ranges. Okay, so I did this all wrong. Okay, so C mat. So here we're again defining sort of the size of each of these matrices and vectors. And so I'm going to have to correct the index, but more or less these are all the same. Three, two, one, 3, 2, 1. Okay. Alrighty, so now we should be getting less errors. Let's save that. Okay, so we're getting one error there. B. Alright, so it's saying it doesn't like this guy right here. So I'm going to check it out. I'm going to pause for a quick second so I can figure out what I did wrong. And I feel very silly. That should not have... These are column vectors, so they only need to be indexed according to the i's. Alrighty, so now that should finally work. And all this is going to do is just run with one set of constraints. We actually haven't added in the binary constraints as of yet. So it seems like I'm loading in this matrix wrong. So it didn't seem to like it because for some reason A mat 1 was not defined. So let's see. A mat 1. That's there. Okay, and I figured out what was going on, so maybe some of you were smart enough to catch it. But basically what ends up happening is I think Cplex sort of runs through this in order. And so it expects to sort of know what J's and the I's are, I's 1, 2, and 3 are, by the time it makes CMAT. But the problem is it's not loading in this data until kind of the end. So apparently there's some ordering to these data files, which actually sort of surprises me. So what you're going to want to do is sort of match that ordering. So once I put it up here, all right, so again, this ordering sort of matches. It actually ran without a problem. Okay, so there we go. Ran without a problem. Okay, so at this stage, all I've set it up to do is, you know, A1x is less than or equal to B. I actually haven't set up these logical constraints yet. Right? So all we've done is set up this constraint, and it's always true. So right now, again, we have max C transpose x such that A1x is less than or equal to B1. Okay, again, this isn't what we want. We want to use these binary variables to sort of turn on and off these constraints. So let's go back to Cplex and define 3 binary variables. Okay, so we're going to have, I guess, 3 booleans, so we'll call it B1, B2, and B3. You could certainly do arrays of booleans, which would be an option, But the problem is if you're using different A matrices, they'd all have to be the same size. If you're to do something tricky where your A matrix is actually a three-dimensional matrices. And then you could do multiple for all loops. But we're going to sort of stay out of that. Okay. So what we're going to do is we want this constraint, again, this guy to be true when b1 is equal to 1. So that's pretty quick to do. So we can say b1 equals 1, equal 1, implies the constraint. All right. At this stage, we can repeat this process for the other constraint, but we're going to have to change this to eyes 2. We'll change this to b2, and we have to change this to amat2 and bmat. Okay, bmat2. All right. The last set of constraints we want to do is the third set. So as of now, so I'm going to rewrite this, we now have b1 equals 1 implies a1x less than or equal to b1, and we have b2 equals 1 implies a2x less than or equal to b2. So we need this last constraint right here. Okay. So let's go ahead and do that. So I'm going to write this as b1 plus b2 equals 0. And then from there, we just have to change all the indices. Amat2 to amat3, and bmat2 to bmat3, and the eyes. Okay, so let's see if this actually works. And sure enough, it works. But you see Cplex gives us a few warnings. So first of all, we never actually used n, though we certainly could. We could put it right in there, so it would help to find the range. The other issue is, because we are able to do this b1 plus b2 equals 0, we actually didn't need to define this Boolean b3. So if we want to make our life easier, we can get rid of that guy. Okay. The problem ends up solving, and we can see what b1 and b2 are, and our optimal x. So this is a pretty neat example of how we can use Boolean variables to turn on and off sets of equations. So hopefully you're able to follow along and make some sense of how maybe you could expand this to a larger problem, especially if you're using Excel or if you have a data file that's already been given to you.